Okay, so getting started on homework 14, you'll notice I gave you the formula for a circle, a horizontal ellipse, and a vertical ellipse. That's the only things we're going to be dealing with for this assignment. If we need more formulas, I will, of course, add them. So, of course, H and K for all of these are the coordinates of the center. And then, of course, R here is the coordinates of the radius. Okay? And, of course, A and B, or B and A, are the major and minor radii of an ellipse, because ellipses are not perfect circles, right? Let's go on ahead and delve into some example problems. So, let's do one easy one and one middle one. Okay. I say 3 and 6. Let's start with 3. First of all, do we recognize that it's a circle? Yes. And there is no h, there is no k, because it's just x squared and y squared, and so it is centered about the coordinate 0, 0. What's the word that we use that also means coordinate 0, 0? Starts with an O. Origin. And so we start at the origin, and to find our radius, we look at the constant on the end, and we take its square root. So now we have to ask ourselves, what is the square root of 64? Well, the square root of 64, you should know that from memory, is 8. Now, you will not count 8 spots from the origin, because look at the graph. What is the interval between 0 and the first marker? 4. So, to go 8, we're actually going to go 2 out, right? So we're going to go out 1, 2, that gets us to 8, right? 4, 8, 4, 8, 4, 8. Now, if we were really fancy, we'd have little compasses. Unfortunately, we're not going to be that fancy, so we're just going to strike the arc as best we can, and if we don't get it perfectly, that's okay, because there is no algebra in heaven, right? But you know there's math other places. Alright, so we strike the arc, we strike the arc, strike the arc, we strike the arc. So we've already identified the radius as 8, and the center is 0, 0. And that's all you had to do for that one. So, that was pretty simple, right? So far, so good. Alright, now, let's take a look at 6. Alright, what is different about 6? Does it have an h and k? Because remember, h and k are subtrahends. They're added or subtracted. Do we have anything being added or subtracted to the x and the y? They're coefficients, right? Are we supposed to have coefficients with a circle? Oh, something's wrong. If it doesn't look like what we want it to look like, we have to make it. And so, what are we going to do to cancel the 3 on the x squared and the y squared? What's the opposite of multiplication? Divide. So you're going to divide everything by 3. So here we have 3x squared plus 3y squared equals to 120. And we divide each of them. I'm going to see if I have a red pen to make that pretty. No, I don't. I'm going to use a pretty purple pen. Ooh, pretty. Okay, divide by 3 here. Divide everything by 3. And with the color resolution, it doesn't show up that great, so forget about that. Alright. So we cancel the 3 here, we cancel the 3 here, and 120 divided by 3 is what? 40. So we have x squared plus y squared is equal to 40. Now, this is where life gets a little bit trickier. We know that the center is 0, 0, right? We know that. To find the radius, we need to take the square root of what? 40. So we know that the radius is the square root of 40. There's just one problem. 40 is not a perfect square, is it? No, it's not. does it have any perfect square factors? 20 is not a perfect square. What's your first perfect square? I heard it. 4. It's 4 times what? 10. So we recognize that 40 is the square root of 4 times 10. And the root of a product is the product of its roots. So we have the square root of 4 times the square root of 10. What's the square root of 4? 2. And so your radius is actually 2 root 10, and that's how you would indicate it. Now, that doesn't really help you strike the arc. That really doesn't give you the points, does it? Now, this requires a little bit of thought. And again, this is one of those where we think about it as close as good enough for the graphing, right? So let's take a look at the graph. Where was our center? I forgot. 0, 0. And $40 is between what two perfect squares? 36 and 49 are the perfect squares, and the roots are 6 and 7, right? 49 is 7 times 7, 36 is 6 times 6. So we know it's somewhere between 6 and 7, right? What are the intervals on the graph? 2. So we're going, now, is 40 closer to 36 or 49? So it's going to be closer to 6 than 7. And since this graph is not very detailed, we'll just have it a little bit off the 6, right? So we go 2, 4, 6, and a little more. 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 And then you strike your circle, and if it's not perfect, that's okay. That's how you deal with imperfect squares. Seven, 8, or 9. Which one would be the most interesting? I like sticking with multiples of 3 myself. Hmm? 9? Okay, now, the first thing it said, it is a circle, given radius, about the origin. So, because it's about the origin, do we have to worry about an h or a k? No, because h and k are both 0. So we know that this is going to be x squared plus y squared is equal to, now, do we just say 3 root 10, or do we have to square that? We have to square that. So we're going to start by saying the square of 3 root 10. Okay. What is 3 squared? 9. So we have 3 squared times the square root of 10 squared, which is 9. Now, square cancels root, and root cancels, leaving us with just what? 10. And if we can't do 9 times 10, we are really in the wrong place, aren't we? So we have 90 is equal to x squared plus y squared, and that is all. Alright, let's see if there's anything on the back side we want to do before I let you work on your own. Everyone good with this first side, more or less? Okay. Okay. Find the standard, let's take a look at 12. Standard form of the equation that passes through the given point and has a center at the origin. This one's just a little more tasty. Okay. Now, what they have done is they've given you a point on the radius. So, put it to you this way. Here's 0, 0, right? Say this is 0, 0. You go 1, 2, 3, 4. We're looking at 12, by the way. 4, 1, 2, 3, 4, 5, 6, right? That gives you the radius, right? We need to find what that radius is, right? Not the midpoint. The distance formula. Now, what pithy theorem is the distance formula based on? Pithy theorem. The Pythagorean theorem, right? If you look carefully, this makes a right triangle. We know we're starting at the origin, so we know that this leg is 4, right? And this leg is 6, right? In this case, it's negative 6 because it went down 6, but we're dealing with distances. So the fact that it's negative doesn't change anything. So, we already know that it's going to be x squared plus y squared is equal to something, right? It's equal to the radius squared, right? Okay. A squared plus b squared is equal to what? C squared. Are we looking for c or are we looking for c squared? Because in the formula of the circle, the radius is squared, right? Okay, so let's just do some easy math. Alright, so 4 squared plus negative 6 squared equals something, right? Now, what's 4 squared? 16. What's 6 squared? And the sum is? 6 plus 6 is 12, right? 52. That is your radius or your radius squared? And the formula wanted your radius or your radius squared? So we just put the 52, and that's it. So to find the radius of 10, we would just square the 2 and square the 3, right? And to find the radius of 11, we would just square the negative 3 and square the 5. Okay. I'm going to let you all work on your own for now, and in a little bit we'll discuss 15. I want you to try 16, 17, and 18 on your own, okay? And we'll discuss 15 tomorrow.